so we will try to discuss this exercise, which is exercise 4.10, page 50. This is the equation. This is the question. Okay. Okay. Exercise 4.10, page 50. Said that there are three forces, F1, F2 and F3. F1, F2 and F3 act on particle A as shown. The first one, determine resultant R in terms of I, J and K. The second one is angle between the R and the x-axis, which is theta R, theta Rx. And the last one is the force F4 if the resultant of F1, F2, F3 and F4 is equal to 0. Okay, so we have three questions here. Okay, so the first one, you need to calculate the R in terms of I, J and K. Okay, so our first task, in order for us to calculate the R, we have to first identify what type of force or what type of method that we can use based on the information given for each forces, and then we can resolve into I, J and K in sum and add everything in X, in Y and in Z. So what we need to do is sigma F equal to R. Okay, sigma F equal to R. So we want to have all forces in terms of I, J, K first. Okay, so let's see the first one, F1. Okay, we have 3D force. Okay, we have 3D force, and then we have several methods, which is first angle method, second angle method, and this one is first, second and coordinate method. Okay, so looking from this information that is given to us, which is the length of the component, which is from A to F1 is given, to this point is given, which is 6, 6 and 7. So we can know the coordinate of this point. So this one we can use the coordinate method. So F1, what we use is, so F1 is coordinate. So we need to find the dx, dy and dz. Okay, so from this figure, this force have to move. Okay, so in order from here to be here, so it move in x direction, which is 7 meter. So dx equal to 7. Go down the y here, so 6 meters, so negative 6, and positive in x direction, z direction, so 6 in z direction. So this is for D. Okay, or if you're using the coordinate here, of course, looking from here, it will be 6, 7, negative 6 and 6, and minus 0, 0 from here, 0, 0, 0, you can get the same answer. And then you need to have from here the D, okay, which is equal to this one, 7 squared plus minus 6 squared plus 6 squared. So you have the D. Okay, so from the calculation, you can have 7 squared plus 6 squared plus 6 squared. Square root of everything, 11. Okay, so you have it as 11. So now the F1 equal to F, which is 2 for 2 dx divided by D. So I write the equation, which is F dx divided by D I plus F dy divided by dj plus F dz divided by D K. Okay, so F1 equal to 2 for 2, 7 divided by 11, I plus minus 6 divided by 11, j plus 6 divided by 11, k. So F1 equal to, okay, so using your calculator you can have 7 minus 11 equal to times 242, 154, 154 Newton I minus 6 divided by 11 equal to times, this is F, 242, 242, so you have minus 132 Newton, or you can write the Newton or not. So J plus 132 Newton K. So we have the F1 in terms of IJK. Okay, so normally to solve this one, you can leave it at this one, but normally I prefer to draw it in the table so that I don't miss any information. So for example, here I have F1. We have 3 forces, so I have F2 and F3, and here is that I have resolved into I, J and K. So I put up the information 154, negative 132 and 132. Okay, so later on this one will be, this one is R, Rx, Ry, Rz. Okay, I add up everything, become Rx, add up here become Ry, and here become up Rz. So first one is done. So look at second example and second forces. Okay, so here we have this one. I have transferred to that part, so I can erase this one. Okay, so second force, which is F2 here, 150 Newton. Based on this information, only one angle is given from this axis. Okay, so let me explain again. If I'm using this one, okay, which is, again, this is X, Y and Z. So the first force is actually downward here. Okay, somewhere this is Y, X and Z. So it is somewhere here, down there. This is the F1. Now we have F2. So F2 is somewhere here. Okay, F2 is here. So you have one forces, one angle given from this force towards the y-axis. This is 60 here, and the other one is on this plane, okay, which is 30 degrees. So what you want to do is you want to resolve this first one into y, okay, one into y, and the other one into plane, okay, into surface x and z, and the one into surface you can resolve back one into x and the other one into z. Okay, so this one we can use the second angle method. F2 second angle method. Okay, so we have F2x equal to F2y equal to F2z equal to. Okay, so look at one by one. We will use the first one, F2, resolve into one into axis y and the other one into surface x and z. So we use 60 degrees, so of course y will be 150 cos 60. Okay, so this one we got directly the answer. And then once we use the y equal to cos, the other one here must be sine. So 150 sine 60, 150 sine 60. But this one is still not finished because we just resolve into surface, into this surface. So we need to again resolve back into one into x and the other one into z. Okay, so I want to resolve this one. Now my force is one here, the other one is in this line. So I want to resolve one into x, the other one into z. Okay, I'm using the 30 degree towards the x, so x will be cos 30. The other one must be sine 30. Okay, so here you must put attention. Be careful, because all the angle is a small angle. you cannot get the positive negative from this angle. So you have to look at the figure, put the sign negative and positive yourself based on the figure. So from here, this force is resolved into here. So y is positive, x is positive, but z will be down the negative direction of positive z. So z must be negative. You have to put that negative because now we resolve into negative z. So you have to put that negative. So calculate that one. You will have the answer as 150. So we have sine 60 cos 30. Okay. 112.5 I 150 cos 60 75J 150 sine 60 sine again sine 30. You will have negative 64.95K. Okay, so now we have the F2 in terms of I, J and K. So now I want to transfer it here. 112.5 75 negative 64.95. Okay, and then we go to the last one, which is F3. So the F3 is actually from this figure. Okay, this is like this one, Y, X and Z. So the F3 is actually in this, like this one, somewhere here, maybe here or there something. Okay, but look at from this side, you will see that it is on Y and Z plane. So somewhere here, maybe up there, but somewhere set here is 30 degrees, so it is down here, somewhere like this one. Okay, so looking from this one, it is only here. Okay, 30 degree given is this one. It is on this plane. It is not actually a 3D force, but it is a 2D force. Looking from this direction, it is a 2-dimensional force. You can see that it is on that Y and Z plane. So it is only a 2D force. You can directly resolve into one into Z, the other one into Y, because it is on YZ plane. So now I want to resolve that one. One go to this one and the other one go to this one, and both is positive. So F3 equal to, you resolve into that. So this one involve Z and Y. So X equal to 0. So 0 Newton I plus Y. So I'm using 30 degree to the Z. So Z will be cos. So this one will be sine. So 100 sine 30 plus J cos 30 K. Okay, so I'm resolving this one into Z using 30 degree to the Z. So Z will be cos, the other one will be sine. And both I'll put positive because it is toward here positive Z and the other one is positive Y. So all is positive. So F3 equal to 0I plus sine 30 50 plus 50J plus cos 30 equal to times 100. So we have 86.6 Newton K. Okay, so I will put it here. So we have 0, 50 and 86.6. Okay, so now we have resolved everything into IJK. So we want to have the R equal to sigma F equal to R. So this one we have R. So we have to add everything here in I direction to get Rx, J direction to get Ry, and K direction to get Z. So I will add 154 plus 112.5. This one is 266.5 Newton I, and then minus 132 plus 75 equal to plus 50. So you have minus 7j, and then here we have 132 minus 64.95 plus 86.6. So you have 153.65 Newton J. Okay. Okay, so the question asks you to find R in terms of IJK. So your answer is R equal to this one, 266.5 Newton I minus 7 Newton J plus 153.65 Newton K. So this one is K. So we have the first answer. Okay, the first question you have answered. The R in terms of IJK, so R, I minus J plus K. Okay, so the first one you have to identify and resolve into IJK, each component, put it in a table, add up everything in R, J and K, and then you get the answer. Second question is, what is the angle between x-axis and the R? Okay, what is the angle between x-axis and the R? Okay, so the question asks you angle x-axis and R, okay, which is theta Rx. Okay, so we can relate this one using the first angle method, because the first angle method said that the theta, the angle given is between the axis and the forces, okay, between the axis and the force. Now the question asks you what is the angle between axis x and the force R. So we can use the first angle method. Okay, so this one we can use the first angle method. Okay, so using the first angle method, what we have here is this one is R cos theta xi, R cos theta yj, R cos theta zk. This is the first angle method. Okay, you want to resolve given any forces, you just resolve into IJK. So using R cos theta xi, R cos theta yj, R cos theta zk. So this one is equivalent to R cos theta x. So theta Rx. Okay, because it is R, so I put R. Theta Rx I. Okay, so you know directly from here. So R cos theta x equal to 266.5 Newton. Okay, this is taken from here using first angle method. If you really understand the first angle method, you know directly it is from here. Okay, but the question asks you to get the theta, not this equation, not R cos theta. So you have to calculate the what is theta. So from here, this is R. So we have cos theta x equal to 266.5 divided by R. So what is R? Okay, I can erase this one. Okay, so it will be 266.5 divided by R. Okay, I have here. No problem. Okay, I have here. So we have here, same as D, we have dx, dy, dz. The d is the square root of dx squared plus dy squared plus dz squared. So same as the R. So the R is the square root of all these 266.5 squared plus 7 squared plus 153.65 squared. So we have the R. Okay, so this is the R. Okay, divided by R, this is the R. Okay, so equal to 266.5 squared plus 7 squared plus 153.65 squared. You have this one, square root of everything, and 266.5 divided by answer, I have 0.866. So cos theta x equal to 0.866. Of course, theta x equal to cos minus 1, this thing. So we have theta x. So I put it cos minus 1 answer. So we have 29.99. So this is 30 degree. Okay, 29.99. So I put that really 30 degree. Okay, so again, you need to understand the thing that is asked for you, the angle between axis and the arc. So you know you can use the first angle method. So this part is arc cos theta x. If they ask you to find the arc y, okay, angle between y axis and the force, you use the y. If asked the angle between z axis and the resultant, you use the z. It depends on the question. You put it here and then you get the angle theta. Good, so that is for the second part. And the last question is, the last question said F1 plus F2 plus F3 plus F4 equal to 0. What is F4? Okay, so that is the last question. Given 4 forces, add one more. F1 plus F2 plus F3 equal to plus F4 equal to 0. So you know that here F1 plus F2 plus F3 is equal to, this one is R. So R plus F4 equal to 0. So F4 equal to negative R. So the way you translate it, F4 equal to opposite of what you have here, negative R. So you put negative in front. So negative 266.5 Newton I. This is negative. You put again negative with positive. Positive 7 Newton J minus 153.65 Newton K. Okay, so you have the answer. Okay, again, the way you solve this one, you have to identify what information is given to you. It is a first angle or second angle, 1D force or 2D force or 3D force. If it is 3D forces, you have to know what information is given to you. Then you can use either first angle method. If the angle between the axis and the force is given, at least 2, the third one you can calculate, or 2D force, the second angle method, where one force is given between the force and the axis, the other one is on the surface. You can use the second angle method, or the dimension is given in terms of maybe box like this one, or coordinate directly given to you. You can use the coordinate method. You resolve everything. I urge you to put everything in that kind of table so that you won't miss anything. Okay, you can leave it in this type, but sometimes you miss the information. So it is good if you can put everything in that kind of tables, and then you add everything in I, become Rx, in J become Ry, in K become Rz, and then you get the answer. Okay, so that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.